Let's do it. Yeah, I am. Hey, does anybody need to take the test right now? Okay. Yeah. The paper one. Yeah. So, you see there that your Bower quiz is Tuesday. That'll be the last grade for the marking period. So I'm hoping to have your test grades done by Sunday night, Monday morning. Rachel, can you pass this? Jabari, grab that. Yeah. I can when I can. I mean, when things are turned in, makeup work in late, they end up getting graded a lot later than the regular one. So I know I said yesterday I thought I could, and then lots of students came in yesterday to work on things. So if you stay after school, it's like a guarantee that I pull it up in my computer and do it. So other than that, it's there's a whole handful of people who are turning those in late, waiting for that to be updated, and I get to it when I can. Okay. Page 657, steps 1 through 3. Let's take a look. Here they are. Step 1, draw the asymptotes. So I really want to emphasize that these dashed lines are the framework of the graph. So looking at the H and K model, those are the numbers that the dashed lines will be at. So I've added a little bit of notes here to the steps. It's not very different from what your book has. Yesterday I talked a lot about whatever would make this denominator 0 is an asymptote. It will match up to the opposite of this H value. And then the K value, 2 out of 3 year graphs yesterday did not have a K value, but the K value is the horizontal asymptote. And then a lot of students want to say, like, I'm not really sure where to start the table. And every table is different. So that's a valid question. Where do I start the table? Where do I start the table? But actually, you could start your table with 10 values if you want. Not really concerned about where the table starts. The center of the table is what's important. The interesting part of the graph is in the middle. So really, what I want to hear, the question is, what is the center of the table? What's happening here in the middle is what counts, not really what's at the end. So whatever value will make this undefined, that's at the center. So when you're thinking about how do I make my table, it's the H value that's undefined, that should be in the middle, and some to the left and some to the right. So turn your page, and this is a great example. Your book really explains this kind of at length. So in the model, it's x minus h. So since this says x plus 2, it's kind of like saying x minus a negative 2. So I think just looking at it and knowing whatever's going to make this 0 is your asymptote is the best idea. So we're going to put this dashed line at negative 2, and you have another one at negative 1. The branches are going down this time because the A value is negative. So they're in the other quadrants, and they have like a negative slope to them. So if the first value is negative, your points will show up in different places. This is the one we're going to do right now. So page 658. I'm going to go through the whole process again right now.
So the final vertical, so do the long fraction there with x minus h, just solve that. Yeah. And then for the k, that just stays as is.
Yeah, it's as is, exactly like it looks. Yeah. So let's get into this page 658, number 6. We'll do it beginning to end. Step 1 is your dashed lines. I'm definitely going to have a dashed line at x equals 1. And why would the dashed line be at 1? Well, that's because x cannot be 1 in this equation. 1 is a false value. It'll come out undefined. We can't put a 1 in there. And so the dashed line shows what the graph can't be. It's like the opposite side of a magnet. You know, you get close, but it pushes it away. It's not really. It's almost like the front side of a magnet, but cannot become the magnet. If you have your own graph paper, today's the day, because it's hard to fit these in these little squares. I'm going to drop this pretty low here, because I know I'm going to have to go up 5. So there's that dashed line. The other dashed line is at y equals 5, and that is because y is excluded from the range. The truth is, y will never be 5 in this equation. So y equals 5 if and only if this is 0. 0 plus 5 is 5. So then we have to question, is it possible to make this 0? And it is not. This will never be 0. So this y will never equal 5. And that's why there's a dashed line through y equals 5. Yeah.
So, like, anytime there's that number right there,
Yeah.
always just, like, jump
You can memorize it. This is the sideways dash line, and then opposite of this number is the up and down dash line. And then this is half credit right now, just getting the framework done. So some students will just swoosh a bit here and swoosh a bit here and get half credit. For full credit, we need a good table. So we're going to take this value that x cannot be. We're going to put it in the center. We're going to call it undefined, and we want 2 points to the left of it and 2 points to the right. So we just move out from there. And I'll do the first one, and then I'm going to pause and have you guys plug in and get your numbers. Try to graph it and ask a question. So this does have fractions. If you want your calculator out, use your fraction button. Very few times do I ever use a mixed number, but right here is one of them. Generally, I don't like mixed numbers, but it's so quick. This is 5 minus 1/2, 4.5. So, and that's 9 over 2, or you can write 4.5. But I'm going to use a mixed numbers because it's the clearest thing to me here. So I'm at -1, 4.5. Now I'm going to pause and let you guys kind of look this over for a minute. Plug in, try to get correct values. Thank you. Boop. Does everybody have the book pages that needed them? I found more books. Okay. 0 for. It's a little bit instinct to curve your line with the axis. So oftentimes I'll see students like drop down next to this black line, but that's points off. You need to move all the way to the red dashed. The y-axis is not our stopping point, the dashed line is. So make sure you move through to the dashed line. Start at a dashed line, curve through the points, end at a dashed line. Two comma 6. Another mixed number, 5.5, or 5.5, or 11 over 2. Burp, burp, burp. Why is this so loud today? And then there's the other branch of the hyperbola. Any questions yet? So now the really complicated stuff, end behavior. Oh no. End behavior will be tested. End behavior was on last chapter's test. So the one that I will not test on is positive, negative. Probably not even increasing, decreasing. Those might be extra credit questions. They're definitely worth your time, especially if you're like gonna keep going into ACE math. So I'll talk about them, but this one will be a test question. On the left side, the y goes up to 5. And on the right side, the y is also going to 5. So that's what's interesting about these graphs is that both ends are approaching this 5. So you want to get your end behavior really understood. As far as it decreasing, it's decreasing everywhere it exists. It's decreasing here, and it's decreasing here. So we just have to really describe where the line exists. It exists everywhere besides 1. So it's decreasing from negative infinity to 1, takes a little break at 1, and then it's decreasing again from 1 to positive infinity. Thank you. And then the last thing, the positive negative thing, this one's an extra challenge. So here's a challenge question for you, for the people in the room ready for a challenge. It's positive above here. So we have to figure out the or the x-intercept. What is this point? That's a challenge question. Does anybody remember anything about x-intercepts? Any interesting characteristics about them? At every x-intercept, y is 0. So we can put a 0 in and figure out what the x-intercept is. So I'm just going to leave it here. Try to figure it out. Someone in here can do it. Find the y-intercept. It'll be negative below the x-axis. You got 1/5? It's pretty close. You know what? You said you did that in your head? It's actually 4/5, which is the other bit of 1. You flip something? I mean, if you came up 1/5, 4/5 is pretty close. So if you subtract 5, multiply by x minus 1, get x alone, you get x equals 4/5, or x equals 0.8. So this point is 0.8. So I'm going to say it's positive from negative infinity to 0.8, and also from 1 to infinity. So it's really interesting, this sliver right here. Actually, I'll highlight it in blue. This tiny little area right here is the only place that the function is negative. So for negative, I would say it's negative between 0.8 and 1. And then it's positive on the left side of that and the right side of that. So anyway, positive and negative won't be tested. It's still in your book and it's still in your assignment. It's still good to talk about, but please really try to figure out the end behavior and how to graph it. So get to your work on your assignment, and you're probably in about 10 minutes. It'll be available online. I am seeing a lot of students